Cancer. There are many evidence nowadays that cancer is indeed an electrical phenomenon. And I would like to talk about this new approach to not only cancer, but to any disease. And I dare to say that whether the disease is degenerative or infectious, any disease is an electrical phenomenon. Because life, in a final analysis, it is indeed an electrical phenomenon. If this is the case, then cancer has only one cause. And this was advanced many years ago by Dr. Albert St. Jorge, when he pointed out in 1941 that proteins, when they are structured, they behave like semiconductors. He pointed out that he didn't believe that these clumsy macromolecules studied in biochemistry were able to play the principal role in the phenomenon of life. And he believed strongly that a tiny particle called the electron was the responsible for many of the phenomena we do not understand yet too well. Then came Dr. Clarence Cohn in 1971, and in my opinion, he is the one who brought the most outstanding breakthrough in the study of cancer, the cause of cancer. Then another step toward a better understanding at that electronic level was put on by Dr. Bjorn Nordenstrom. He taught the world, indeed, that any disease was an electrical phenomenon. And he started a new electrotherapy to treat successfully cancer. So, if these cells, these sick cells, the cancer cells, can react to electrical currents or electrical fields, this implies immediately that around the cell we must have a tremendous electrical activity. Now on the blackboard we will see what do we know up to today, 1991. We have the cell, which is protected from the environment by the cell membrane made out of lipids. It's a bilayer lipids. Now, embedded, we have proteins that go across the membrane. And in 1971, Dr. Cohn from Virginia, by that time, biochemists, biologists, biophysicists, they had measured what is known by the name of transmembrane potential. And what they discovered was that the cell shows a voltage across the membrane. The interesting thing, if we move to the right, is that when the cell is in the resting phase, the transmembrane potential E in somatic cells is roughly or approximately equal to minus 70 millivolts. When the cell goes into division, in other words, we're talking about the mitotic phase, this transmembrane potential changes to minus 15 millivolts. Or we may say that the cell has been depolarized electrically. Here comes the observation of Dr. Cohn, which is this one. He observed that every cancer cell remained constantly, the transmembrane potential was, the one across the membrane, was constantly equal to approximately minus 15 millivolts. That means that this cell was in constant, permanent division. But this is the definition of cancer, the uncontrolled proliferation of cells.